All right, Jenna, here are the problems that you had sent me that you wanted to go over from your assignments this week. Thank you for getting with me to go over these. That's actually really awesome that you did that, and I'm glad that you did, and I hope this video helps. If you still have questions when I'm done, please send them to me, and I'll be happy to go over it a different way or, answer any of those questions you have. All right, so the first one you sent me was question 3. Determine which postulate can be used to prove the triangles are congruent, and if they can't be proven congruent, then write not possible. All right, so here's my picture. I don't want to zoom in that much. Here's my picture of my two triangles. It looks like one big triangle, and it's split up into two smaller triangles, okay? And we have to prove that those two triangles are congruent based off of just this picture. So what are our choices? When it says tell which postulate, what are they talking about? Remember we talked about CPCTC, and we use this is corresponding parts of congruent triangles are congruent. We use this postulate or this rule basically when we can prove that all three angles of each triangle are congruent and all three corresponding sides of each triangle are congruent. So we're proving 6 things congruent. This one we don't use as much because we have shortcuts, right? So our shortcuts, we had 4 of them, were side, 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 angle, angle, side, angle, and angle, angle, side, right? Those are our shortcuts. So if we can prove that all 3 sides, all 3 corresponding sides of both triangles are congruent, then we know everything about the triangles are congruent. If we can prove that 2 sides and the angle between them are congruent, then we can prove that everything in both triangles are congruent. This is 2 angles and the side between them. And then we had 2 angles and then a side of our triangle that's not between these 2 angles, right? So these are all of our choices. We're going to look at this picture and see which ones work. And I see you had said angle, angle, side, or SSS. You were partially right. SSS could work, right? Because I see that these 2 sides are congruent to these 2 sides. That's only missing one more side, right? And this third side of each triangle actually is shared. It's the same exact line segment. So whether it's used in that top triangle or the bottom, either way, we know it's the same line segment, so it's the same length, whether it's in the top or the bottom. So then I can say that these triangles are congruent because all 3 sides are corresponding, or all 3 corresponding sides are congruent, right? So it would be this guy. So you were right with this. So where we kind of missed it a little bit was this angle, angle, side, okay? The only other thing you need to remember here is your properties of an isosceles triangle, right? Take this entire big triangle, like, I can't draw, without the line down the middle, just the whole thing, and it has this side marked congruent to this side, right? Which means when we have 2 sides congruent, that's an isosceles triangle. It means this third side is our base, right? So whenever we have 2 congruent legs of a triangle, the angles across from those sides are congruent as well. The 2 base angles are congruent. So this angle has to be congruent to this guy, which means this guy has to be congruent to this guy, right? This side is across from this angle. This side is across from this angle. So now I have a side, an angle, and a side marked congruent to a side, an angle, and a side, which is SAS, right? And then nothing else works, and all of our choices here only offer you 2 options. So which option has SSS and SAS? The one right next to it here, B. So you were close. You got it half right. We just had to remember the isos, and it wasn't super obvious. You had to kind of dig back in your brain, remember those facts from the lessons here that this quiz is on, this assignment. But when we have 2 congruent sides, that means we have 2 congruent angles. The side and the angle that aren't congruent are our vertex, the top point, and our base. Our base is not congruent to our legs, and our vertex is not congruent to our base angles. But our base angles are congruent and our 2 legs are congruent, okay? Hopefully that helps. And then number 5 and 6 actually had to do with this picture right here. So I brought this picture over, and for number 5, it says if the measure of angle HJM is 145, HJM is this angle right here. So if this is 145 degrees, find the measure of MHJ. MHJ. J. So this guy right here, this little angle, I'll mark it with 2. Okay, so what I want you to remember here again is that this is an isosceles triangle. If I smeared my pen a little bit. If we're looking at, oh, that looks nasty. If we're looking at this long, skinny triangle, right, the 2 legs are marked congruent. This side is marked congruent to this side with these 2 little markings here, which means the angles across from them are congruent, right? This is our vertex, so the side across from it is our base. Those 2 are one off. They're not congruent to anything else. But our legs are congruent and our 2 base angles are congruent. So if I know all 3 angles add up to 180 and I know the 2 of these angles are the same, I could call their measure, I could call it x, right? So if this one's x, this one has to be x as well. And then I know that 145 plus 1x plus 1x has to add up to 180, right? And then I can just solve for the measure of one of my base angles because I'm only looking for this guy down here, right? So I have 145 plus 2x. This is just your algebra. Subtract 145. You're trying to get x all by itself. So these go away, and I'm left with 2x equals 35. And then divide by 2 to get x by itself. So x is going to equal 17.5, right? 17.5 degrees, which makes sense because if this is one big humongous angle, if all 3 have to add up to 180 and most of that 180 is up here in the vertex, 145, that doesn't leave very much degrees measurement for each of these base angles, right? So it makes sense that it would be 17.5 degrees. That's teeny tiny, just like these look. So this would be the correct answer here. And that was another isosceles triangle property that you had to remember. All right, and then we had number 6. If the measure of angle G is 67, find the measure of GHM. So now we're looking at this huge bottom triangle here. So it says if the measure of angle G, here I'll write it in green, is 67, find the measure of GHM. So we're looking for this angle now, okay? Well, what I notice about this guy is that this side is marked congruent to this side. So these are my 2 legs of my isosceles triangle, and this bottom side is the base. So if this is the base, that means this 67 is one base angle. So this side would have to be another. This angle would have to be another base angle, and base angles are congruent. So each of these is 67. And if these are 67, what would this one have to be for all 3 to add up to 180? Right? So we'll call this one X or whatever you want to call it. It's a different problem, so it's a different X. You can call it Y, whatever you want. X plus 67 plus 67 all has to add up to 180, right? So X plus 2 times 67. 2 times 67 is 134. Oops, X plus 134 equals 180. And then to get X alone, I have to subtract that 134 from both sides of my equal sign. And I'm left with X on this side equals 180 minus 130 is 50, and 50 minus this other 4 is 46. So this angle measurement up here, this, what is it, MHG or GHM, this angle has to be 46 degrees, which would be this guy. Hopefully this is helping. Let me know if not, and I'll be happy to go over it a different way. Okay, the next one, this is just all one problem on this whole sheet, was question 7 on the proof. All right, so it gives us this picture, and it says, write the reason for the missing part of the proof. It gives us the given, what we have to get to with our logical reasoning, and we're missing this reason right here. So we're just gonna kind of go through the steps, right? We know this, we know the picture, and whatever it tells us here. So based on those facts, we're trying to prove that AB is congruent to AC, right? This entire side is congruent to this entire side. That's what our goal is to get to. Okay, so given the top here, it says DE is parallel to EC, these 2 lines that are marked parallel, and angles 1 and 2 are congruent, these 2 guys. Okay, so that's all it tells us in the given. So in our proof, we're not writing the proof. They did the whole thing. We're just missing one little part. It first started with the parallel statement in the given, right? So based on that parallel statement, we can say a couple things, right? If I know that these two lines are parallel, think of it like, remember when we went over angle relationships, and we have parallel lines cut by a transversal, right? And then here we have angle 2, and here we have angle 3. These are corresponding angles. So when our lines are parallel, which ours are here, corresponding angles are congruent. So 2 and 3 are the same size, and 1 and 4 are the same size. So that's what they said here. Angles 1 and 4 are congruent. Angles 2 or 3 are congruent because they're all corresponding angles, right? And corresponding angles are congruent in a triangle. When our, not in a triangle, in any shape, when our two lines cut by the transversal are parallel. Okay, so then next, so that's done. They said they were congruent, moving on. Next, they went to the second part of the given. Angles 1 and 2 are congruent. So they listed that out. Why? Because it's given. Based on this and this, what can we say here? Well, it says angles 1 and 2 are congruent. Oops, sorry. 1 and 2 are congruent. We just said 2 and 3 are congruent and 1 and 4 are congruent. So if I know 1 and 2 are congruent, 2 is the same as 3, 1 is the same as 4, can't I just say that then 4 and 3 are congruent? That's what they're saying here in this next line. Angle 3 has to be congruent to angle 4. So then we get to our reason. Why can we say that? What rule is in place? So here you said alternate interior angles are congruent. Alternate interior angles are in between two parallel lines on different sides of a transversal. So they would be in here, we'd have an angle here and here, or like here and here. We don't have any angles outside of our triangle in this picture, so we don't really have any alternate interior angles here. Interior, again, doesn't mean inside the triangle. It means in between our two parallel lines. If each side of the triangles are transversal, we'd have to have angles on both sides of the transversal to have alternate interior angles, and we don't. So that one doesn't work. But for this, it kind of seems like a substitution problem. If I know these two are the same, and these two are the same, and these two are congruent, then these two are congruent. Seems like I just substituted, right? If 1 is congruent to 2, and 1 is the same as 4, and 2 is congruent to 1, and 2 is congruent to 3, then I can just substitute 3 in place of 2, and 4 in place of 1, and say 3 and 4 are congruent. It's a lot of talking. I know this is confusing. It's kind of like the transitive property, right? When we cut out the middleman. If 1 and 2 are congruent, and if 2 is congruent to 1 and 1 is congruent to 4, then I can just cut out the 1 and say 2 is congruent to 4, right? And if 1 is congruent to 2 and 2 is congruent to 3, I can just cut out the middleman and say 1 is congruent to 3. So if 2 is congruent to 4, 1 is congruent to 3, and these two are congruent to each other, we're just saying 4 and 3 are congruent. So this was a tough one, and we can kind of use it using process of elimination, but the answer to this one is B. Congruence of angles is transitive, okay? Let's rule out the other two, because I think that'd be easier. Corresponding angles are congruent. Well, in our proof here, when we started by saying 1 and 2 are congruent, so 3 and 4 must be congruent. 1 and 2 are congruent, so 3 and 4 are congruent. 1 and 2, 3 and 4, they're not corresponding, right? If I said something about 2 and 3, these are corresponding. Or if I said 1 and 4, these are corresponding, but 1 and 2 are not corresponding, and 3 and 4 are not corresponding. So there's nothing really to do with corresponding angles in this statement. So we rule that one out. And then supplementary angles are congruent. We have no idea what the measure of the angles here are, and supplementary angles would be consecutive interior, all three angles of a triangle. Those would be supplementary, right? They would add up to 180. That's not a situation we have here. We're not talking about these two angles. We're talking about these angles and these guys and these being the same as each other. So we can rule out the supplementary thing. That doesn't work either. And again, we talked about why the alternate interior doesn't work. So the only one kind of left is congruence of angles is transitive. Transitive means you cut out the middleman, right? Remember the transitive property is if A is equal to B, and B is equal to C, then we can just cut out the middleman and say that A is equal to C. That's all we're doing here. These two are the same, and these guys are the same. Then these have to be the same. Just transitive property. We're just transferring this congruence over to these guys when we have the parallel lines. I hope that wasn't too confusing. I know that was a tricky one because we never have gone over this outright. We have, but not in this wording. So that was tricky. Okay, and then the last one that you had sent me was question number 10. Determine whether triangle DEF is congruent to PQR given the coordinates of the vertices and explain. And you don't have to explain, it's already written here. Okay, so all it tells us here is 6 points and where each of those 6 points are on a coordinate plane. So it tells us triangle DEF, so we know these 3 points go with triangle DEF. And it tells us we have triangle PQR, so we know these 3 points go with PQR. Right? So we're going to go ahead and plot these points. You don't have to. You don't have to plot these points. I'm a visual learner. I don't know what you're comfortable with, but for me, I got to look at it and see what I'm looking at. So D is at negative 6, 1. So I'm going to go, here's my x-axis. I'm going to go back 1, 2, 3, 4, 5, 6, and then up 1. That's D. E is at 1, 2 over 1 up 2. And F is at negative 1, negative 4. So I'm going to go backwards 1, down 1, 2, 3, 4. There's F. So there's triangle DEF. And these are not straight lines, but they're supposed to be. Okay, and then triangle PQR is at 0, 5. So over 0, up 1, 2, 3, 4, 5. I'm going to do it in purple. Right here. Q is at 7, 6 over 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3, 4, 5, 6. And R is at 5, 0. So over 1, 2, 3, 4, 5, up 0. So these are the 2 triangles that we're talking about. P is this over 7, up 6, Q, and R. Okay, so the question is, are these congruent? Well, they look pretty congruent, right? And I'm not a great drawer, but they kind of look congruent. So I have to figure out mathematically if they are. I can't guess. I have to use rules of math, right? When all we know is where the vertices are, we don't know anything about angle measure, right? We have no idea what size angles these are. Are they 30 degrees? Are they 50 degrees? Are they all 60? Is it equilateral? We don't know, right? And there's no way for us to measure the angles. The only thing we can measure is the length of each side using the distance formula. So the only way that I can prove these 2 triangles are congruent is using the SSS postulate, which is when all 3 sides of one triangle are congruent to all 3 corresponding sides of another triangle, then I know the triangles are congruent. So here's where the long tedious part comes in. I have to use the distance formula to find the length of all the sides. So it's kind of time consuming. I'm going to do it here. You can always fast forward if you don't want to listen to it. Remember, our distance formula is the square root of x minus x squared plus y minus y squared. And when we're finding the distance between 2 points, this point is at x comma y, this point is at x comma y. So it doesn't matter which x you start with first here. If I start with the x that's here, the x that's here, it doesn't matter. But whatever x I start with here, I have to start with its partner first here, right? So I'm going to get these coordinates from up here. So first I want to find the length of side DE. D is at negative 6, 1. E is at 1, 2. It's this top side here, DE. Okay, so negative 6 minus 1 for x minus x. Oops, here I'll do DE. Square root of negative 6 minus 1 squared plus, and since I started with negative 6 here, I have to start with its partner y first when I subtract my y's. I did negative 6 minus 1, so I've got to do 1 minus 2 for the y's. And then I just simplify, right? Negative 6 minus 1 is negative 7. Negative 7 squared is positive 49. 1 minus 2 is negative 1. Negative 1 squared is 1. This is all under the radical. And when I simplify, I get square root of 50. If I actually take the square root of 50, I get a long random, a long drawn out decimal. And I don't really care what the number is at this point, so I don't need to change it to a decimal. I'm just gonna be comparing it to the other sides, right? Is there a side in this triangle that has a length of square root of 50? That's what I care about. So I don't care what the number is, just is it the same as another? Okay, so I did DE, now I'm gonna do EF. I'm telling you this is long and tedious. If you wanna check yourself, make sure you put the numbers in the right spot, you can. So for EF, I'm gonna do 1 minus negative 1 squared plus 2 minus negative 4 squared. 1 minus negative 1 squared plus 2 minus negative 4 squared. Okay, and then of course whenever I have minus and negative, when I have two minus signs, they become one big plus sign. When you're subtracting a negative, it's really adding. I know that sounds funny. 1 plus 1 is 2, 2 squared is 4. 2 plus 4 is 6, 6 squared is 36, and this is still under the radical, and that's equal to square root of 40. So there's the other side. Now I want to find this last side, DF, right? And then I'll have all the length of all three sides of my first triangle. So from D to F, I'm going to do negative 6 minus negative 1 squared plus 1 minus negative 4 squared, all under the radical. And you have your problems in front of you, so I don't have to keep moving back and forth. All right, negative 6 minus negative 1 squared plus 1 minus negative 4 squared. Okay, and then of course my double minus signs turn into plus signs. Negative 6 plus 1 is negative 5. Negative 5 squared is 25. 1 plus 4 is 5. 5 squared is 25, all under the radical, which gives me square root of 50. Okay, so the length of three of my sides of one triangle are these guys right here, right? Looks like it's an isosceles triangle because two sides are the same length. Okay, so now I want to find the length of all the sides of PQR. All right, so first one, I'm just going to do this quickly. I'm not going to go back and forth to look at the coordinates. Okay, so the side of PQ is 0 minus 7 squared plus 5 minus 6 squared. This is negative 7 squared, which is 49. This is negative 1 squared, which is positive 1. And when I add those together, I get square root of 50. So far, it's looking good. I have at least one side that's the same. Okay, next side, PQ, QR. I'm going to find the length of side QR based on those coordinates given in the problem. So 7 minus 5 squared plus, where am I at? 6 minus 0 squared. 7 minus 5 is 2. 2 squared is 4. 6 minus 0 is 6. 6 squared is 36, all still under that radical sign. And when I add it together, I get 40. Okay, so far this is looking good because I've got a side that's square root of 50, side that's square root of 40. As long as the last side is square root of 50, then my two triangles are going to have all the same sides congruent, so we'll be congruent. All right, so PR is the last one. And that is 0 minus 5 squared plus 5 minus 0 squared. Is not congruent. Okay, so 0, sorry, I thought you had marked the right answer for a second. I was like, what? Wait, we're doing this the same way, and she marked the right answer, but it is not. It turns out something different. Negative 5 squared is 25. 5 minus 0 is 5. 5 squared is 25. And when I add those together, I get square root of 50. Okay, so we can see right now that my three sides of that second triangle are square root of 50, square root of 40, square root of 50. The first triangle, square root of 50, square root of 40, square root of 50. So they're the same. They're all the same, right? So when all three sides of both triangles are the same, the two triangles are congruent by side, side, side. So that would be this guy right here. The triangles are congruent by S, 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 since the corresponding sides have the same measure, right? They're congruent. We don't necessarily know they're corresponding. Sometimes this triangle could be twisted, but it could still have the same length sides. Okay, so hopefully that helps a little bit maybe. You weren't too far off with anything. So I don't feel like you were totally lost, but if you're still confused, please let me know. Thank you.